I've been asked to do an evaluation on these for a Qualcast battery, 18 volts lithium ion. I think they've been sold by a well-known high street chain of shops. The complaint being about these is that the run time has been drastically reduced from when it was new. So the customer said they were running for about 6 minutes at the moment, where they used to do about 20 to 30. Now runtime is highly subjective, so I'm going to do a proper test on these at the capacity, charging them up. That's the battery, that's the charger sent in by Mr. Johnson. So we'll have a look at that for him. The first thing we'll do is to check the current voltage, or standing voltage on this. 19.8, so they're thereabouts fully charged. Now I'll plug the charger in, see if that gives me any readings. Oops, wrong range. 21.4 volts, that's about right. I think his output was about 21. What I'll plug the charger in. I'll plug the battery into the charger. That's got a green LED on at the moment. Unplug that first. It's only going one way, I presume. Okay. The LED's gone to red, so I assume that's going to be a change of state LED. It'll either turn green or go off when it's done. I'll put my phone there for time reference. So 1945. I'll keep an eye on that and see how long it runs for. This may be irrelevant. It's only from charging it from flat. It'll give me the charging time. And that was quick. 12:49. About 4 minutes. Okay. The LEDs turn green. See if the voltage is increased on this. .4, so it's gone up about 0.6 volts. Okay. Next step will be a discharge test. I believe this Qualcast is from a cordless strimmer, a capacity of 2000 milliamp hours. For the discharge test, I'm going to be using this apparatus, the West Mountain Radio, well-known battery testing device. And because I haven't got any corresponding parts for the contacts, I'll just improvise a couple of strips of brass and some crocodile clips on the other end of those. I can't get everything in shot on the screen here. The laptop screen's too big, but that's the setup. To the improvised contacts, I'll do a screenshot of this when it's done. So let's input some figures into the test parameters. We may be able to work that out. You can see that on the screen. Set for lithium ion, 18 volts, 5 cells, capacity 2 amp hour. Test name Johnson and test it. So let's test it to its capacity first. Let's go for about 5 amps. It's about the maximum this charger can take. And cut to volts 14 and 5 by 3. Let's call that 15. Probably 5 cells in there, 3 volts each. Let's go. That's high. Okay, yes, go for it. It's dropping down to about 18 volts. Let's work in voltage and the load. That's running at 89 watts. So the limit on this unit is about 100 watts, so that should be fine. Let that run and see what happens. Oh my god. Oh dear. Yes, I know. Test time 4 minutes 31. Amp hours 0.372 at the top there. Wow. So it's either the cells are very low capacity, maybe a problem with one of the cells, or it's the charger not putting sufficient charge into it. Okay. So what I'm going to do now, I'm going to charge the battery pack up again from flat. I'm just going to test it for temperature. It's barely warm, about 25 degrees, something like that. So the customer said it was running for about 6 minutes, then let it rest for an hour, run for the further 4 minutes. I thought it may have a temperature problem with the heating up of the cells, but I wouldn't have said so now. So let's charge this up again with a charger and see how long it takes. It should take, which it says on the back there, 3 to 5 hours. I think the customer said it was only charging for about an hour and a half. So let's charge it and see. Okay, so we're starting charging at that's not turning red for a start. That says the LED green. It was red last time. Ah, that's why. Do it right. So charging time starts at 13:15. I'll leave that there. The unit's not running now, so just keep that in view as well. Yeah, just about. Okay, 13:15. And that's been charging for about 20 minutes. The one thing I haven't done is, well, I've just assumed that the charge actually works. So it is warm. I've got no way of actually seeing if it's actually outputting any current up till now. So I'll put a clamp meter on the charger. See that into shot, whether that can be seen. This is outputting 0.6 amps. Okay, that's fine. Let it run. Well, now the LEDs turn green. 14, 10, 50, 55 minutes of charging. So for only charging for, let's call it an hour, at 600 milliamps. So this battery pack is only taking 600 milliamp hours in as a charge. So that's never going to give me 2000 milliamp hours output, is it? I'm going to bring the laptop back in again and do another charge. I know what to expect, but in the interest of fairness and thoroughness, we'll test it anyway at a lower discharge rate. So after that last charging, do a discharge test again, this time at a lower milliamp hour. Set this up again to power, put it down as test 2. Let's discharge it at, let me see, 0.2C, a fifth of its capacity, it's about 400 milliamps. This could be a waste of time, but we have to do it anyway. Cut off voltage on 15 again. Oops. Where's my screen gone? So on a lower discharge, it's up here somewhere. It's showing 20.3 volts. Ah, there it is. It's a blue line. So we'll let that run its course and come back when it's finished. Wow, what a difference in capacity readings. We see that on screen. 1.4, was it? 1.492 measured amp hours. This is on the 400 milliamp discharge rate. That ran for 223 seconds. What's that? 223 seconds. 223 minutes. It's nearly 4 hours. Okay. Now this tells me that the cells are more likely to be okay, since it's discharged all the way on the low rate, but only that amount on the higher discharge rate. I think that leads me to believe that, say, inside this pack, say there's probably five of these 18650s, but they're probably low discharge cells. That is, the cells only capable of giving it about 5 amps, and then the voltage collapses, as you see there. So maybe they were high discharge when new, but they certainly don't like it now after about 30 or 40 charges. So what I'm going to do, again for thoroughness, I'm going to charge it up again and give it one more test. So charge it up again. Right there where that can be seen. Again, I'll make a note of the charging time, starting at 1854. So, it's last turned to green, 21:51. Between 2 and 3 hours. I've been watching it that closely, but checking it every hour. So between 2 and 3 hours. Okay, so time for the last discharge test. So the last discharge test. Let's reset the parameters again. So it'll be test 3, 15 volts. I'm going to set this on about 4 amps this time, see how it'll perform. Which is slightly better than the 5 amp one, which is an abject fail. And go. Oh dear, for a second time. This is on the 4 amp discharge. Follow the violet line. What did that give me out here? 0.39 amp hours. Again, no good on the higher amperages. That one's fine. How long did it last? 6 minutes. So that ties in with what the customer said. It ran for about 6 minutes. So by deduction, the strimmer is going to be taking about 4 amps. Right, I'll gather my thoughts and do a conclusion for this. Before I do a conclusion, I just wanted to say that I haven't taken this battery apart. In doing so, it would invalidate its warranty if it's still got one. So on to my conclusions, or my opinion, based and backed up with a little bit of fact. Let's start with the charger. I've seen it's charging for about a maximum of 3 hours, which is okay. It's not bad. It gave me this discharge, so it's mostly charging, so shall we say. Let's go onto the battery. What did it give me? First, the good news. This discharge curve gave me, let's call it 1500 milliamp hours, which is less than its 2000, about 25%. This is okay if you're going to use it as for a torch or something like that, something low drain. But the strimmer is not a torch. The strimmer is going to need 4, 5, 10 amps, maybe even more. It depends on the load, depends how thick the weeds are, I suppose. So in this instance, this battery is a fail, and it's not fit for its purpose, just with 6 minutes of running time. Addendum. I feel the need to compare the test results that I've had with another battery pack, and to that end I made up a new battery pack. 18650 cells, whether those can be read, capacity of 1500 milliamps, and these are high discharge cells. They're good for about 18 amps. So I've charged this. I'm going to test it, same again, and overlay it against the original graph and see how this one performs. I had intended to overlay it over the original graph, but mistakenly I started a new graph. But no matter, that is so much better. That's what I expect from a battery pack like this. If the camera could be seen on screen, I'll do a screenshot as well. 1375 milliamp hours. Test time 16 minutes 33 seconds. That's better. I'm going to charge it up again in case it was a fluke, and then do as I intended originally, overlay it over the original graph. Same as before, ready for a test. Croc clips going to the units which you can't see. Trying to short those out. Same again, 15 amp cut off, 5 amp discharge. That's the second test complete. I've got the same results again. Measured amp hours 1389 milliamp hours. Test time 16:43. About 10 seconds more than the last one. It's more than anything else. You can see the difference here. I'll get rid of this test here, because that's the low discharge one, 400 milliamps. The strimmer's never going to run at that rate, so that's irrelevant. Let me, excuse me a second, just hide that one. So this is what we want to see, a comparison. This is the new pack, that's how long it ran, and these are the 4 and 5 amp tests on the original pack. What more can I say? I'll put a screenshot of this or something on the end of the video. I hope that's been useful.